Okay, Bismillah, Assalamualaikum warahmatullahi wabarakatuh. This will be for the final bit of chapter 2, which is section 2.9, which deals with dot product. Hopefully you can still hear the voice clearly, because I have to bring in the fan, switch on the fan because the aircon is already off. It's already 10 p.m. here. But anyway, we have covered how to deal with vectors in chapter 2 from resultant forces, resolving forces, resultant vector, resolving vector, and also how to get vector into Cartesian vector form, be it using coordinate direction angle, be it projection angle, and also the latest part with using the unit vector based on the position vector, right? Now, dot product is basically how to say? It is a mathematical tools, right? Dot product, I believe some of you or most of you have used it before. Dot product, right? We have covered it before, but maybe you do not know where to apply it. So statics, there are two applications of dot product which we will cover after this, right? So that's why there's a special section on dot product, right? Okay, so in terms of the objective, if you refer to the slide 2.9 dot product, there are two objectives. One is to determine angle between two vectors, and second, to determine projection of vector along specified line. So that is the two applications where we can use dot product to get whatever we want. Number one is the angle, number two, projection. Right. If we deal with 2D, right, there's two parts of this. One is angle, two is projection of force, right? So we'll focus on the first one first. To get an angle between two line or two vector, right? In 2D it's quite simple, right? For example, if you have something like this, what is this angle, right? So that's quite straightforward actually, right? If you get any triangle, you can do sine, cosine, whatever, right? But in 3D, it will be much more tricky to compute, right? For example, if we have, I don't know, if we have something like this and something like this, what is the angle between this, right? How to get this one, right? So because each of these line is somewhere in the 3D space, to get the angle is quite tricky if you want to use the conventional 2D method, right? So the easiest way is using vector operation, right? And that is why dot product comes into the picture, right? Okay, so first and foremost, what is dot product and how is it? What is the definition, right? So if we have two line, let's say, right? Can you see the line there? Hopefully it is clear there. Alright, so and if you have a vector here, this is vector A and B, right? And the angle between the two vectors is given by theta angle, right? Okay, so the definition of dot product is we will have A dot B equal to A B cos theta, right? I'm assuming you have seen this already before, right? I think in mathematics or something you have learned about this before, right? So A dot B equal to AB cos theta. Make sure the way you write, again I want to focus on this, I have mentioned this before, how you write things must be correct in terms of representing what it actually means. So when you say AB, meaning magnitude A multiplied by magnitude B multiplied by cos theta, right? This one must have an arrow because it's a vector, this one must have an arrow because it's vector, and dot is not just like that normally, right? We have to make it clear like that to differentiate it between multiply and dot, right? Dot is not multiply, right? Do not confuse the two, right? So A dot B equal to AB cos theta, right? Now, so that's basically dot product is that, right? But several things that we can appreciate here. If you notice on the left side, right, on the left side, this one and this one, right? This is a vector. This is a vector. When you dot, it becomes a scalar, right? Because if you can imagine, A have ijk, vector B have ijk, but when you dot it, it becomes a scalar. Right? Here is just number, right? There's no I, no j, no k, right? And the unit will be just multiplication of the unit, right? For example, if this is Newton, this is meter, this will be Newton meter, become Newton meter or something, right? If this is meter and meter, become meter square. So the unit is just multiplication of the unit of both A and B, right? Alright, so that's basically the characteristic of dot product. Alright, so now if you go to the slide, there's basically I and j. Basically, what is that all about, right? Now, if we imagine, okay, here, right? If I have my vector A as vector I, and then vector B is I, right? What will this A and this B becomes? I will give you 10 seconds to think about this. Okay, right? So if A is I, vector A is vector I, magnitude A will be, it should be 1, right? Why? Because I is a unit vector, the magnitude is 1. What about I? Is another 1. And then cos theta, right? What is theta? So theta by definition is the angle between the two vectors, right? And when the two vectors is actually the same I, so it becomes 0. So what is cos 0? Cos 0 is 1, right? So 1 multiplied by 1 multiplied by 1, you get 1. What about I and dot j? If you have I dot j, you get 1, 1 cos. What's the angle between I and j? You get 90 degrees, right? So you get 0. Okay? So you'll notice that when I and I, j and j, k and k, because it is the same line and the magnitude the magnitude of the unit vector is 1, you'll get 1. When I and j, I and k, j and k, j and I, k and I, etc. Because it's perpendicular, cos 90 is 0, right? So that makes it easier when, because originally it's like this, right? For example, okay, let's give you an example. A vector is 1i plus 2j plus 3k, right? And vector B is 4i plus 5j plus 6k, right? Let's take that as an example. Now, if we have A dot B, what you have to do is basically this whole thing dot this whole thing, right? For example, 1i plus 2j plus 3k dot 4i plus 5j plus 6k, right? So the normal operation is like this. So this and this, this and this, this and this, and then this and this, etc. Right? Meaning like 1i dot 4i. How to do that? So 1 and 4 becomes 4, I and I becomes 1, right? And then 1i and 5j becomes plus 5, 0. And 1i plus 6k plus 6, 0. And then 2j dot 4i becomes 8, 0. 2j and 5j becomes 10, 1. 2j and 6 6k becomes 12, 0. Then 3k and dot 4I becomes 12, 0. Then 3 and 5 become 15, 0. 3k and 6k becomes 18, 1. So you actually, everything that is perpendicular becomes 0, everything that is on the same line becomes, meaning I and I becomes 1, j and j becomes 1, k and k becomes 1. So actually what you need to consider is just I and I, j and j, k and k. So basically what you get is just this and this becomes 4, because it's 1, 4 times 1 is 4, right? 2 and 5 become 10 times 1 is just 10. 3 and 6 becomes 18, k and k is 1, so you get something like this. So you notice that it's just become a number, right? 18, 28, 32, right? So from 2 vector it just becomes a number. So that is what dot product gives you, right? So this is an example of the manifestation of this, right? So if you need to dot to vector, right? So I hope you understand already, right? So you just consider I and I, j and j, k and k, right? This becomes 4, 10, 18, and then you can calculate, right? So that's how calculation of dot product mathematically, right? So we will go to the application in statics. Now, in the application of getting an angle, right? From this, right? If you know vector A, if you know vector B, you can get the magnitude, right? Because if you know the vector, the magnitude is just square root of square, 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 right? So by knowing these two vectors, you can actually get to know this magnitude, and from there you can get theta actually, right? So if you have any 3D problem where there's an angle between the two things, so as long as you can get two vectors from the two lines, you can actually get what is theta between the two lines. So that's the idea, right? So is there an example? Okay, in the slide they actually go for the two things straight away, right? One is about the angle, one is about the projection, right? So I'll just give you an idea first, right? Before we go to the actual example later on. If we have something before, right? Like you have a pole, and then you have a cable here and cable here, right? Something similar from previous section, right? In a 3D space, right? Where, for example, this is A, B, and C, and between this line there's an angle theta, right? Between the two lines, the two cables there. So what can you do if you need to determine theta without anything is given? Because if you want to consider normal trigonometry, it will be like suffering without end, right? So we have this one, it will make your life easy, right? What is important is just, if I know this vector, then it actually resembles this one, right? So I can use dot product to get theta, right? So what you do is, for example, because the vector is just any vector, A and B is just, it can be force, it can be unit vector, etc., right? So in this case, the easiest is, if I know coordinate of A, if I know coordinate of B, I can know R, A, B, correct? Right? Just this coordinate minus that coordinate. Similarly here, if I know coordinate A and C, I can get R, A, C. Right? We have learned that before in 2.7, right? Now, if you know this one, can you know what is R, A, B magnitude? You can, right? It's square root. This one, R, A, C, also square root of this one, right? So if you know this already, then you have all the ingredient to use this one, right? You just use, let's say this one becomes RAB dot RAC. It will be RAB RAC cos theta, right? And because you already know this one, you know this one, you know this one, you know this one, you can calculate theta, right? So that's the idea of application, right? In the exam, there will be something like this. Sometimes they ask, what is the angle between something, right? And of course, this is where you have to be able to decipher a question, because in the question, you will not see any diagram like this. Right? There's no arrow, there's nothing. There's just a pole and two cable, right? So you have to be able to determine, okay, from what I've learned, how to determine theta. One of it is dot product. Can I use dot product here? Yes, I can, as long as I can get this vector and this vector. Can I get it? If I have coordinate and coordinate, I can get a vector, right? And then that's how we process things. All right. So that's how you use dot product to compute angle between two lines. All right. The example will come after this, because the slide goes to the theory first. So we go to the determining of projection of vector. So this is about projection, right? Another application that we can use dot product. All right. All right. What is a projection? Now, a projection of a vector is something like this. If you have a vector like this, right? A. So we use A, alright. And then there's an axis like this, for example. To make it easy, let's name this axis A, because they use that one, axis A, right? So if the question says, what is the project? Sorry. What is the projection of this vector on this line? Right? Basically, the idea is the same as what is the component on that axis. Right? It's basically resolving force. Right? And if you remember resolving force, meaning that you have something like this, right? Where this is perpendicular, so this is a parallel on A. So if you have the parallelogram, you actually have the other component, which is A perpendicular to A, right? Okay, I'm not sure how to label this, but basically this is A on parallel to this axis. This is A perpendicular to this axis. Right? So you have two axes there. Right? Now, when we see projection, is this one. This A projected on this line A, capital A and small a. Right? Now, in the normal calculation, if you have theta here, obviously this is simple enough, right? What is A parallel to A? It's just A cos theta. Right? Meaning, from this triangle, where this is perpendicular, so this component here is just A cos theta, right? Hopefully you can follow that one. Right. Now, that is in 2D. It's simple enough. But in 3D, it can be complicated, right? Especially if you do not know theta, right? So if you have any force and any axis here, what is the projection? So there must be a better way. There must be an easier way to calculate, right? Now, let me ask you to imagine a little bit, right? This side here, right? Is it resemble something here? Right? If you put here, it will have like this, A cos theta, right? Meaning it have two similar elements. One is A, one is cos theta. Right? How to make it the same? How to make A B cos theta is the same as A cos theta? Now, to make it the same, is if B is 1. Can you understand that? Meaning that if A is A, B is 1, theta is theta, then AB cos theta becomes A cos theta because 1 is just 1. Right? Now, if you do that, on this side what should happen? Because this is A, this should be A vector, right? Vector of A, then you get magnitude of A. Vector of A, you get magnitude of A. What should be here on this B, vector B, when the magnitude is 1? What vector have a magnitude of 1? It will be what? It will be unit vector, right? Correct? Unit vector. Now, by definition, A dot P equal to A B cos theta. What is A and B? It is how to say? The two vector that give the angle, right? So in this case, what are the two vectors that give the angle theta, right? So one of it is A, meaning this A gives the vector A, right? Okay, so the other one should be this one, right? So what unit vector is on this line? It's basically the unit vector of that line, right? So basically, because A cos theta is the same as this one, so you can calculate this by this one. Vector A dot unit vector of axis A. Right? So that's the understanding where it comes from, right? But if you just want to memorize for answering exam, so you can get A parallel to this axis is vector A dot unit vector of A. But okay, because I said A, so this A is the projection one, this magnitude. This A vector is this original vector A in terms of Cartesian vector form, IJK. This unit vector is the vector of this line, the unit vector of this line, where the magnitude is 1, right? So you can use this one to calculate. And hopefully you understand what I'm saying here, how we try to match to use the dot product, right? Anyway, it becomes like this. Okay, do you understand? Okay, so because this is dot, it becomes a scalar, right? It's just a number. So that's how we can use dot product, because this is dot product, to get a projected component. Alright? So if you do this, you don't, even if you do not know theta, as long as I know the vector here and the vector there. Right? So in terms of application, it's still the same. Right? For example, use the same example as before, right? If we have the pole, for example, right? The pole, and I have, for example, one cable like this, right? Let's say this cable have this force here, right? F. And the question says, what is the projected component of this F on this pole? Meaning something like, what is this one, right? F parallel to pole, for example, right? The component on this one. How to get when you do not know theta? So by this one, you should know, okay, if I want this one parallel to this one, if I can know what is vector of this F, and I can know what is the unit vector of this pole, I can calculate, right? So if I know F parallel to pole, in this case, should be F vector dot unit vector of pole, right? So that's your starting point. Okay, I can apply this one. Of course, after that, you have to find out how to get this vector. And this vector, again, if you know the magnitude, how to get the Cartesian vector form, you just use what we have learned before, right? For example, you know this coordinate, you get R vector, and then R magnitude, and then unit vector, and then F is just F times unit vector. And make sure you understand unit vector of what, because unit vector here, what the one that I just said right now is unit vector of this line, right? That is for this F. This unit vector is for this different line, right? So how to get this unit vector? Still, you can use the same understanding before, right? If I know this coordinate and this coordinate, I can get r vector. If I know r, I can get r magnitude square root. If you got this one, you divide, you get the unit vector of this one. Right? Hopefully you are following what I'm telling you. But that's the idea of the way you can process what's going on. From whatever question is given, you read it back. Okay, projection component, I can use dot product. But dot product require the two vector. How to get the vector? So this vector, I can use coordinate, etc. Okay. This vector, I can use the coordinate. Okay. So you start, you plan your work that way, and then you go from the coordinate r, u, etc. Right? So it's not difficult, inshallah, as long as you understand. Any question? Okay, sorry. You can. But if you have any question, do write on the comments. Hopefully, I will read it before class, before next class. So if any pressing question, I can prepare for it, inshallah. If anything is not clear, right? Hopefully it's clear, but if anything, do ask. Not a problem. Right? Okay. Do note that this is in scalar, right? If the question actually asks, what is the vector of this one? Right? So you have to be able to understand that from before, right? Because I'm not going straight forward in the step by step as the slide, but there are some things that, for example, if you need A parallel A in the vector form, right? This is scalar, right? If you need the vector, what do you do? 5 seconds. What do you do? Basically, you just multiply by the unit vector, right? So A parallel to A, unit vector A. Just like before, just like force magnitude, if you want to get vector, force magnitude times the unit vector of the line, right? So similarly, this one you get to become vector, you just multiply by unit vector. So this is something. Sometimes in the slide or in the textbook, they combine the two things. Right? For example, A parallel here, the magnitude is this one, right? It's actually A dot UA and then UA. Right? Sometimes they combine multiple process. Right? For example, like this. So this one is just from this one is this dot product. You get this one. This one is just multiple. Just this one, right? So I prefer not to confuse students like that. So I just do separately. This one is one step, this one is one step. As long as you understand, you can do step by step. Right? Hopefully you can decipher what is the meaning of this when you look at the textbook or the slide. Right? And also the slide also touch on, if you already get a parallel, what about a perpendicular? Right? So it does cover that also. So please do cover that one, because that one is again back to trigonometry and back to the basic of vector, right? Resultant vector, etc. Okay, so go through it, and if you don't understand, please ask. Alright, we'll go straight into example 1. Okay, so this one can be erased. So I leave the equation there. Alright. So it's already 10:30 p.m. Alright, so example 1. Basically, it's already given. The f is already given in Cartesian vector form, if you notice the slide, right? So that's to make you easy to calculate. It's very straightforward. And then, okay, find the angle between the force vector and line AO and the magnitude of the projection of the force along line AO. Now, actually that's two questions in one, right? The first question is the angle, the second question is projection, right? So we will do one by one so that you don't confuse, right? Now, to get the theta, right? Again, in any given problem, make sure you can decipher what is important points, right? So in this case, if you need to determine theta and you want to use, that's the first thing. Okay, I need to determine theta, I can use dot product. Dot product is A dot B equal to AB cos theta, meaning I just need the two vector. I just need the two vector, right? Alright, so in that case, one vector is already given, F. This is already given as minus 6i plus 9j plus 3k kilonewton. Right? Obviously this k is vector, this k is kilo. Right? And then you have another line. Right? The blue line. From A to O. Right? And the theta is between these two. Okay? That's the important point. So what you need to be able to think of is, okay, I just need the two vector and the two magnitude. Right? In this case, one vector here, another vector here, right? What vector can I get here? The easiest one is, if I know the coordinate, is R, right? R, A, O. Now make sure the direction is correct, because right here, from the same point, it should go out from the same point, right? So it should go in this direction. So meaning R, A, O. Right? So once I get this two vector, you can proceed with this equation, right? So coordinate. What is the coordinate of A? Okay, what's the coordinate? 1 minus 2, 2, right? 1 minus 2, 2, correct? 1 minus 2, 2. That's coordinate of A. Coordinate of O is 0, 0, 0, right? Alright. So what is R, A, O? So O minus A. Right? So 0 minus 1 is minus 1i. 0 minus negative 2 is plus 2j. 0 minus 2 is minus 2k meter. It's in meter, right? Now, I have the two vector, right? This one vector, this is one vector. But you need these two magnitude, right? So you need magnitude of F, you need magnitude of R, A, O. Is it easy to do? Straightforward, right? So square root of minus 6 square plus 9 square plus 3 square. You get the answer there. This one again also square root of minus 1 square plus 2 square minus 2 square. Oh, you get your answer there, right? So now you have all the ingredients needed. You have vector F. So basically it will be like F dot R A O becomes equal to F times R A O times cos theta, right? Is it in the picture, in the frame? Yes. So this one is settle, we can get theta, right? Now, of course, one thing that, because I'm not going to in the calculation too much detail, I just want to show what is going on, and you can follow the steps, right? You can calculate yourself this one and this one, right? Right. However, what do you do with this F dot RAO? This is the what we have covered before, right? How to dot two vector, right? F is this one, minus 6i plus 9j plus 3k. RAO is minus 1i plus 2j minus 2k, right? So when you do dot in this side, it becomes what? So minus 6i and minus 1i becomes positive 6, right? Minus 6 and minus 1 is positive 6. I becomes 1, so no problem. So 9j and 2j becomes 18. 9 and 2 becomes 18. And then 3k and minus 2k becomes minus 6. That's what happened with f dot RAO. Right? Meaning this one dot this one. So it should equal to f is whatever magnitude here, multiplied by RAO is whatever magnitude here, cos theta. And obviously you can calculate what is theta, right? And you can follow the slide also for the confirmation of the answer, and you get 57.67 degree. Okay, hopefully you have followed that one. So that's only the first part of the question, which is what is theta between f given and the line, the blue line OAO. Alright, now the second part, which is what is the projection of the force along the line AO, or the blue line, right? So what's that all about? So that is the second part, which is you have the force already, F, and then you have the line AO there, right? What is the projection? Meaning something like, okay, this F parallel to AO, parallel to line AO. What is this component? That's the question, right? What is the magnitude of the projection of force along line AO? So that's the thing. How to get this one? Recall back, if you just memorize the equation, what is it? So F parallel to AO is just this vector dot unit vector of AO. Right? So vector this one dot the unit vector of the line becomes the projection on the line. Right? So that's from, I have erased it, but you can rewind to how we get this one just now, right? And yeah. So in this case, just as long as you get this and this, you get this one, right? That's the answer. That's the question. So in this particular question, F is already given, right? But over here, IJK in the question already have. So this one is straightforward. What about UAO? How to get this UAO? Now, if we continue from what we have left just now, we already have calculated what is RAO vector and RAO magnitude, right? In this case, to get UAO is just simply UAO is just vector RAO divided by magnitude RAO. And then you have this already, and then you do dot product, you get the magnitude of the force projected on the line AO. Okay, my battery is dying. Anyway, hopefully we are already towards the end, inshallah. Right, so and if you see the slide, then you do the calculation, you get 6 kilonewton there, right? And of course, it also shows an alternative way to calculate, because in this particular question, we already calculate beforehand what is theta, right? So in this case, when you already know theta, this one is simply also F cos theta, right? So the answer should be the same, and you can prove it by calculating both, and it will give you the same. Now, for some of you say, isn't this easier? Just F cos theta? Yes, it is easier once you get theta, right? Now, how do you get theta? It's still using dot product before, right? So you still have to use dot product somewhere. If the question do not ask for theta, it straight away asks for the projection. So sometimes it's easier to calculate using this one, because if you calculate theta first and then calculate F cos theta, then you have the additional steps. But it's up to you which one is easier, right? Yeah. But when you do multiple steps, make sure you check to avoid any mistake. For example, if you already have a mistake in theta, when you do F cos theta, then it will already be a mistake, right? So yeah, be careful on that one. Okay. Okay, we have another question. Okay, this question is quite interesting because of the shape of the bracket, right? Because I'm seeing my battery is dying, so I'm wondering, can we go until the end? Okay, I'll pause for a bit and change the battery first, just for safety. Wait a minute, I didn't bring my battery. Anyway, so I'll have to rush quickly here. My battery is in the office. Alright, so we go. Alright, so in the group problem solving, if you see the slide, it's under group problem solving. There's a bracket. You have the bracket with the angle there, right? So this is quite interesting, not because the question is difficult, it's just because the shape may cause you some difficulty if you do not understand how to deal with it, right? Now, so the 300 Newton force is acting on the bracket. Find the magnitude of the projected component of this force acting along line OA. So make sure you understand the question first. Okay, the question says what is the magnitude of that force, the projection of that force along the line OA, which is the blue line. So this is basically the concept of, if you have the blue line and you have the force, what is the projected component, right? It's that one. Meaning that from there you should be able to think, okay, the equation that I will use is what? F parallel to a line is F vector dot unit vector of that line, right? You should be able to think of that already, right? Then what it means is, okay, I need the force in vector and I need the unit vector of the line, the blue line, right? So as long as I can get that, I can calculate with using this equation, right? So that's the first thing that you should be able to tell. Before you calculate anything, what is this question one? Oh, it's projection on a line. So I have this equation already in my mind. This magnitude is force, the original force in vector dot the unit vector of the line. So that's the only thing that you need to think about, right? So in this case, so both of the force and the unit vector will be quite interesting to calculate because it is in the slanting angle there, right? Right. So for the force, how can you determine F in terms of Cartesian vector form? What is X component, Y component, and Z component? Right? So let's do this. Make sure you can visualize this first, right? Because it is, or the bracket is slanting, and the force is along that slant, but having an angle there, right? So you have to do the two triangle, right? You have to do the two triangle. Okay, the first triangle, if you see the diagram in the group in the slide, is the shaded gray shaded area, right? If you draw the triangle, it will become something like this, right? The shaded one, where this is 30 degrees, right? And this is the 300 Newton. Okay, this line here is still on the slanting line, right? We'll just name it F prime there. And this one here is actually the y-axis, right? If you notice, this one is along the y-axis. So this is Fy, right? So with that, what is F prime based on this 30 degrees? So it's 300 sine 30 degrees, and Fy is 300 cos 30 degrees. Alright, so that's the first triangle. Now, hopefully you can imagine the second triangle, where if you look from the side, it is the one that is open up like this, 30 degrees, right? If you look from the side, you should see this 30 degrees, right? So from that angle where it opens up 30 degrees, that triangle there, right? So if you see that one, what is this line? That line is actually this line, right? The f prime. So this is f prime, which is actually 300 sine 30, right? And what is this on top there? That's x in the negative direction, of course, but this is fx, right? And then what is this height? This one here is fz, right? Okay, so fx, then this will be f prime sine 30, right? This will be f prime cos 30. And given that f prime, we already know this value, so you just plug in. So in this case, 300 sine 30 sine 30. In this case, you plug in here, you get 300 sine 30 cos 30. Right? You just plug in the f prime with this value that you already get. With that, if we put back into the Cartesian vector form, fx is this one, but notice that it is in the negative direction, that it goes back. So it should be negative this whole thing, negative 300 sine 30 sine 30 I, right? And then for y is this one, plus 300 cos 30 degrees. J is plus, right? Because it's positive y. And z is going up, so plus 300 sine 30 cos 30 k. And this is in Newton, right? Okay, by now I do expect you already have watched the trigonometry video and you have tried some example after that, right? So these two triangles you should already know how to deal with already. If you haven't and you haven't seen that video, please do so. Do yourself a favor. Do not you put yourself into a hole that you cannot dig out of afterwards, right? I want you to pass the subject, so make sure to check that video out, to understand, to try, so that you understand how to deal with the two triangles, right? We have to do this a lot. In 3D, some of you might have already know how to do this straight away, right? You can imagine, okay, sine, cosine, etc. Once you have done this a lot, that can happen. But before that, for those who have never done this a lot, please do try and draw your two triangle. Make sure you understand that. Alright, so that's the first one. That is this one, right? Meaning this one is settled. The F. Alright? That's only one part of it. The whole thing here is just to get F. What about UA? What about UA? Alright. We have a place here. Let's try to do it here. Okay. Because I just do not want to drop that one yet. So A is unit vector of that line OA, right? Okay, so you have point O to point A. Is it in the picture? Yes. So unit R OA, right? Unit line ROA. So so as long as you get the coordinate, you can, right? So O is 0, 0, 0. A is, okay, this is where it gets interesting because of trigonometry. How to get coordinate of A. Right? How to get coordinate of A. So A is, X coordinate is, okay, it's on the back, so it's minus 300 plus 300 sine 30, right? 300 plus 300 sine 30. Okay. Y is 300. Z is 300 cos 30. 300 cos 30 degrees. Okay, anyone have any problem to get that? To get this coordinate? If you see what is going on, okay, make sure you can imagine how to get the coordinate, right? Now, for this x coordinate, make sure you can imagine if you look from that side, right? If you look from the side, okay, there's not enough space. So I'll grab this out, right? I'll do this so that we have the space. So if you look from that side, you'll get x-axis like this, z-axis like this, right? If you look from the side, and okay, this. Okay, let me redraw. So you have like x-axis and z-axis like that, right? And this is the negative x-axis, because if you look from that side, x is to the left, right? Right? I hope you can imagine which direction I put. When you look it from the y-axis, you look at the axis, you get x to the left and z upwards, right? So from there, basically the bracket, you will look something like this, right? Something like this, and then it goes up, right? Where this is 300 and this is also 300. However, that 300, this one is making an angle of 30 degrees here, right? So the question is, what is the x coordinate? X coordinate must be this one, right? Meaning that 300 plus whatever that is. And this is, what is this? 300 sine 30, right? So this whole thing is 300 plus 300 sine 30, right? 300 plus 300 sine 30. And this whole value must be negative because it's on the negative side. So the coordinate will be negative 300 plus 300 sine 30 in the bracket. Y should be straightforward, right? If you look from that axis, y is just that way, 300, right? And z is this one, right? Is height here. Is height here, which is 300 cos 30. Alright, so once you get this coordinate and this coordinate, ROA, can you get ROA? So ROA is coordinate of A minus coordinate of O. So this one minus 0, you get that one, I. 300 minus 0 plus 300 J. 300 cos 30 minus 0, you get 300 cos 30 K. That will be the vector you plug in here. Right now, you already have force vector, you already have unit vector of the axis of the line. You can dot, you know how to dot. So I with I, J with J, K with K, you get a value magnitude. That will be your final answer. And if you see the slide, the final answer is, where is it? Where is it, the final answer? F.U 242 Newton, right? Now, in the slide, they actually show both way. Both way, meaning that I'm using straight away this one. But there's another way where you use F parallel A is F cos theta. However, you don't have theta in this question, right? So they use dot product actually to get theta. So they use like F dot unit vector, for example, of A of OA becomes force times 1 times cos theta. So they get theta, plug in here, they get F cos theta, etc. Right? So that's another way. So if you see the slide, it actually jumbled up two methods in one go. So it can be confusing if you do not know what's going on, right? So I just show just this one is simpler, straightforward, and you get the answer. It's not here, but you get the answer in the slide, which is 232 Newton. Both way that you try, f cos theta or this one, you get 242 anyway, right? But if you use cos theta, it will be longer actually in this particular question, right? So why to bother? I'm too lazy to do long calculation. I choose to use shorter calculation. That's my preference. So that's why I don't choose long calculation. Anyway, so that's the end of 2.9. Alright. So we have reached the end of chapter 2. Hopefully you have learned a lot. And all of this is still the very basic of statics. Meaning that a lot of this will be used in small portion, meaning in later chapter, these all things that we have covered in chapter 2 will be, for example, part of it. Starting point, for example, right, to get the force in Cartesian vector form, for example, etc., etc. So make sure you resolve any question that you have, anything that you're not sure, make sure you resolve it straight away, do not delay, because when you go to another chapter, there's a lot more to learn, and in terms of answering the question, it requires you to understand this first. So do not delay to understand all of this, all of chapter 2 basically. Alright, so it's already 10:55, it's almost 11 p.m. here. I'm spending a lot of night recording this video for you. Hopefully you appreciate it. I'm not saying appreciate it to me, but use this material. Meaning I have prepared all the material just for you. Hopefully you take advantage of it and benefit from it, inshallah. Wallahu alam. Make dua for me, inshallah, that my health is okay, because living like this might not be the healthiest way. But anyway, hopefully this is beneficial for you. And yeah, any question, do comment. Especially if you need me to prepare something for the next class, if anything not clear, right? Remind me if I forgot to do some of the things that I said I wanted to do. For example, yeah. Wallahu alam. Subhanakallahumma bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Wassalamualaikum warahmatullahi wabarakatuh.